Hello, class, and welcome to this evening's notes. Tonight we will be talking about transformations from Chapter 12, Section 2, and Section 3. So we're going to begin with translations. Translations are a type of transformation you have done in the past, whether in junior high or elementary school, or even as late as algebra. So translation, remember, is the slide transformation. It's where I'm going to move an object or a coordinate point to the left or right and then up and down. So we're going to start with a little practice so we can get some notation down. So if I have the coordinate point 1, 4, and I want to move this coordinate point to the left 3 units and down 2 units, then what's my new coordinate point going to be? So if I want, I can graph this. I'm just going to do a little sketch here and then move my sketch around. But I also want shortcuts because I don't want to always have to graph everything and move it around. But here we go. If I do 1, 4, here's my A pre-image. And I'm going to go to the left 3, 2, 3, and then down 2, 1, 2. And then what's my image now located at, or what's happening? So if I want to take my x-coordinate, and to the left means I'm going to subtract 3, and I take my y-coordinate, I'm going to subtract 2, then doing this algebra should give me my new image, or my image. So let's see, 1 minus 3 is negative 2, 4 minus 2 is 2. And if we had counted, we went 3, that's negative 2, and 2. So my new image, or my image, A prime, is at 2, negative 2, comma 2. And there's a couple of ways I can use this notation. So we can write it out in words, left 3, down 2. There's also a way I can write it, x minus 3, y minus 2. It's kind of directions on what we did. And then the last way is vector notation. Vector notation looks similar to the coordinate point, but instead of having parentheses, you're going to have these greater than and less than signs. So this is a way to tell you how to translate a coordinate point without writing it out in words or showing you in this algebra. This is vector notation. All right, and then if I was going to map it, which we've been mapping our points, I would say A was at 1, comma 4. I'm going to do the little arrow and do A prime. And A prime was at negative 2, 2. So this mapping notation that we're going to work with. All right, so you received 2 examples in class, 2 questions. We're going to do one together here in our notes, and then we will do the other one in class together. So, first one, it says, a builder is trying to level out some ground with a front-end loader. He picks up excess dirt at a coordinate point and then maneuvers through the job site along these vectors. Find the coordinates of the unloaded dirt and then find the single vector for the loading point to the unloading point. So maybe he has to move in these vectors because he has obstacles in his way. So you were given a piece of grid paper, and I noticed that 916 is kind of far out, so I'm only going to show my first quadrant. And then we probably will even run out of some room. So what's going to happen if that becomes the situation? That's why we need the algebra to work. All right, so I'm going to tape it down just so it won't move. So anytime you need to pause, go ahead and pause, and you can draw, and then you can restart it again. All right, so 9/16 is at 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 16. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So here's where our dirt originally begins. So now we need to follow these vectors. So I'm going to follow these vectors in order and see where we're going to end up dumping our dirt. First one says vector negative 6, comma 0. So this means I'm going to move a negative 6 in the x direction. 1, 2, 3, 4, 5, 6. And 0 along the y. So I don't have to move up or down. So we're going to take the dirt here. Check. Then it says 2, 5. So 2, positive direction, and then 5. 1, 2, 3, 4, 5. Now I'm beginning to get off my grid paper here. And I have the dirt. Now it says to move 8, 10. Well, 8 I can do and still be on my grid. 1, 2, 3, 4, 5, 6, 7, 8. But if I move 10, notice I'm really off my grid. So we need to start thinking about what coordinate point this is. So if I moved 8, right now I'm at 17, 18, 19, 20, 21 in my y coordinate. And I have to go 10 more. So without counting up on my paper, I'm going to add 10 to 21. So that my dirt is going to be dumped off at a y coordinate of 31. So now we just need to count and see what our x coordinate was. Went from 9, 10, 11, 12, 13. And our dirt gets unloaded at 13, 31. So that takes care of the first question they ask us. Find the unloaded dirt. Now it says find a single vector from the loading point to the unloading point. So I want to know, how did I get from 9/16 to 13/31? So I'm going to compare along the x-axis. I went from 9 to 13. So I added 4. And from 16 to 31, I had to move in a positive 15 direction. So here's my vector. Maybe I didn't have anything to drive around, and I can go straight from picking up my dirt to unloading my dirt, and that would be my vector. All right, so your second question we will do in class. You can save it. And now I want you to go to the left-hand side, and we're going to talk about rotation. All right, so rotation, we know from our previous classes it's the turn, and we have two kinds of turns. We have fixed turns, or what you consider a pivot point turn, like you do in basketball, or we have rotations about the origin. So the ones we're going to be visiting with in geometry are rotating about the origin. All right, so we have two types of rotation. We can rotate clockwise, so if you think about the way we go on a clock, or we can move counterclockwise when we rotate moving to the left. Counterclockwise is the most popular, so if you just kind of want to star this one, that's how we count in algebra in the coordinate plane. So we start with quadrant 1, 2, 3, 4, and they move in a counterclockwise direction. If you want to think about the unit circle that you will see in trigonometry, it opens in a counterclockwise direction as we move. So this one is the most popular. If they don't tell you how they're rotating, then this is the direction they want you to rotate in. All right, so I do want to do an example with you. We are going to talk about 90-degree rotation and 180. And then in class, we'll pick up the 270 and the 360. So if you need to pause and write down these examples, then feel free to do so. All right, and welcome back. I have already plotted my point A and my point B, and we're going to do a 90-degree rotation with point A, and I'm going to do a 180-degree rotation with point B. And then I'm going to give you the rules. So first I kind of want to show you a little shortcut on how this works. Okay, so point A is at -1, 2. And I want to rotate point A 90 degrees in a counterclockwise direction. So if you can plot this, and you have movable paper, which most of us should, then all I have to do is turn it. So if I'm turning it to the left, I'm going to physically turn my paper left. Now what I want to do is count the points. Okay, now it's at -2, -1. So turn your paper back to its original position and graph -2, -1. If I had turned my A coordinates 90 degrees in a counterclockwise direction, this is where it would be located. Does that kind of make sense if I move it down? So it went from -1, 2, is now located at -2, -1. And we're going to talk about the rule. All right, so let's take a look at coordinate point B. If I want to do B, and this time in 180 degrees, remember that's like two 90s, so I can turn my paper twice. So I'm going to turn it to the right. Here's one time, that's 90 degrees. And here's my second time. Now I'm going to count. That's at -3, -1. So when I turn my paper, 1, 2, 3, -1. Now I have B prime at -3, -1. So let's take a look at these coordinate points and see if we can find a rule. For my 180 degrees, it's probably a little bit easier. Notice I went from +3, 1 to -3, -1. So all I had to do was negate my coordinate points. If it was positive, it becomes negative, and if it was negative, it becomes positive. On my 90-degree rotation, I do a little bit different. It went from -1 and +2 to -2 and -1. So first, notice that y became the x and x became the y, and that my y coordinate was negated. So here's a little rule. I flip their positions, and then I negate the first one. So if it was negative, it becomes positive. If it was positive, it becomes negative. So we'll have some more examples of those in class, and the more you work with them, the easier they are to handle. So I look forward to seeing you in class. We will talk about 270 degrees and 360 degrees. Then you have a little project of your own. So thank you and have a great night.